Aromaticity. Criteria for aromaticity. Any cyclic compound is said to be aromatic if it satisfies the following three conditions. First condition is planarity, that is the ring must be planar. Okay. Second condition is complete delocalization of pi electrons. ये मैं समझाऊंगी आपको एक एग्जाम्पल में. The third one is the ring must contains 4n plus 2 pi electrons where n is a whole number, that is n may be 0, 1, 2, 3 etc. And this is known as your Huckel's rule. This 4n plus 2 pi electrons, any ring, any compound which contains this number of pi electrons obeys the Huckel's rule according to scientist Huckel. Hence aromatic compounds have delocalized electron cloud of 2, 4, 6, 10 and 14 pi electrons. Okay. Now we'll see the example one by one. First of all, this is the structure of benzene. Now you will see here, this is a cyclic ring having planar structure. Okay. Planar means all the atoms are present in the same plane. Okay. Now second is complete delocalization of pi electrons. Here these are nothing but what? This is the pi bond, double bond, one single bond, pi bond. Now this pi bond, these are pi bonds. Okay, so this pi bond, there is a delocalization takes place. That means this pi bond can move from this position, this bond goes to this position, again this will come from this position. So there will be form of another resonating structure of benzene ring. So delocalization is possible. Complete delocalization of pi electrons takes place because alternatively single bond, double bond is there. Third one is, so if 4n plus 2 is equals to 6 pi electrons, 6 electrons, so 4n equals to 1, n equals to 1 means it is an integer. So it obeys the Huckel's rule. Huckel's rule satisfied, hence the benzene is an aromatic compound. Similarly, another is your naphthalene. In this compound, there are two membered rings. This is cyclic planar structure, complete delocalization of pi electrons. And how many pi double bonds are there? 5 double bonds. That means 5 single sigma bond and 5 pi bonds. 5 pi bonds means how many pi electrons? 10 pi electrons. So 4n plus 2 equals to 10, 4n equals to 8, n equals to 2, which is an integer. That means it also obeys the Huckel's rule. That means naphthalene is also an aromatic compound. Okay. Third example is cyclopentadiene. Cyclopentadiene is cyclic and planar structure. Complete delocalization of pi electron is absent here because here there is no that means alternative single bond and double bond is there. Here double bond, two single bonds, again double bond. So no alternative single and double bonds are there. So there is a delocalization is not possible here. Okay. It contains how many double bonds? It contains 2 double bonds. That means 2 sigma bonds and 2 pi bonds. So 2 pi bond means 4 pi electrons. So according to this, when n is equals to 0.5, it comes n equals to 0.5 or fraction, which is not an integer. Hence Huckel's rule is not satisfied. That means cyclopentadiene is not an aromatic compound. Similarly, another example is cyclopentadienyl anion. Now cyclopentadiene और cyclopentadienyl anion में क्या फर्क है? यहाँ पर extra pair of electron, lone pair of electron is there, which also contribute to the aromaticity. Okay. So here these 2 points are same. Only the third point, it obeys these two conditions. Third point is here total 2 double bonds along with one lone pair of electron is there. So all total how many? 6 pi electrons are there. So 4n plus 2 equals 6, n equals to 1, which is an integer. Hence Huckel's rule is obeyed. Okay. And the cyclopentadienyl anion is also aromatic compound. Compound is a cyclopropenyl cation where it obeys those two conditions. This is cyclic planar structure, complete delocalization of pi electron. Now here what happens? It contains one double bond only. One double bond is 2 pi electrons. So 4n plus 2 equals to 2. So n equals to 0. 0 is an integer. Hence Huckel's rule is satisfied. So cyclopropenyl cation is also an aromatic compound. Okay.